So this first video is going to review significant figures and scientific notation. Significant figures, just as they were in your first chemistry class, are all the digits you can actually measure, along with the one estimated digit, the uncertain digit in your measurement. Any non-zero digit will always be a significant digit, or a sig fig. The zeros are the ones that we have to kind of talk about a little bit more. So in the first column in the table, non-zero digits always count as significant figures. So 4.35, those are all non-zero digits. So that measurement would have 3 sig figs. Then we have the leading, the captive, and the trailing zeros. I liken leading zeros to the pages in a book, such as your table of contents and all the publication information. They're not pages that you have to read to understand what's happening in the book. So leading zeros come before any non-zero digit, and they will never count as significant figures because you can always write that number in scientific notation and still show the relative size of it. So 0.015 kilometers, there are 2 leading zeros. The first non-zero digit is a 1, so that particular measurement has 2 sig figs. Captive zeros are like the middle chapters in your book. Most often you can't skip those middle chapters and really understand what's happening. So the zeros that fall between non-zero digits, such as the 2 zeros between the 4 and the 5 and 40.05 seconds, would always count as significant figures. So that particular measurement would have 4 sig figs. If you take those zeros out, there's no way to write that number without changing it. Finally, we have the trailing zeros. These are the zeros found at the very end of a measurement. And these are the ones that play games a little bit, and so sometimes a book ends on a whimper, and sometimes it kind of has a neat twist at the end. When you have a decimal in your measurement, the zeros at the end are like the twist in the book. Those are kind of critical. They are there because they were measured precisely. So in 30.0 amperes, we have 2 zeros at the end of that measurement. We have a decimal between the 2 zeros. You could have more zeros follow the zero after the decimal. It doesn't matter. They would all be considered significant. So in this particular measurement, there are 3 sig figs. In 30 moles, however, there is no decimal present. This is one that's ending on a whimper. Most likely that is a rounded number based on a calculation, and so that particular measurement would only have 1 significant figure with the 3, because that trailing zero is not indicated to be precise. It's not indicated to be significant. There's something else I was going to say, and it's dropped. I'm sorry. If I remember it, I'll come back to it at the end. Adding and subtracting. When we are adding and subtracting, we want to keep in mind the precision in our measurements. Basically, the fewest decimal places is the measurement that is the least precise. Sometimes a measurement won't have any decimal places, and your least precise digit will come prior to the decimal. But based on whichever digit is the least precise, that is how many places you want to report your answer to. With multiplication and division, those are calculated a little bit differently. We don't have to line those up by decimal places, so we just look at sig figs. The measurement with the fewest sig figs determines how many we have in our answer. And then if you happen to have both addition, subtraction, and multiplication division in a calculation, you need to follow your order of operations. If you've got something in parentheses, you would apply that rule first, and then you would apply the other one. But you do have to apply both rules if you have both types of operations taking place in a calculation. So let's do a couple of examples here. We're going to determine the number of significant figures that are present. So 2.03 is being multiplied by 4.1 times 10 to the negative second squared. 2.03 has 3 sig figs. The 4.1 times 10 to the negative second is in scientific notation. There are 2 digits before the times sign, so it has 2 sig figs. That would be your fewest number of significant figures. So after you square the 4.1 times 10 to the negative second and you multiply it by 2.03, you get 0.0034, or 3.4 times 10 to the negative third. I'm double checking in my calculator real quick. You do want to make sure you take care of the exponent before you do the multiplication. I don't think that's drastically going to change your calculation since it's all multiplication. I got 0.00341243. So those leading zeros do not count. the 3 and the 4 do count, and the 1 does not cause the 4 to round up, so we leave the number as is. And in a problem like this, unless I specify the form in which I would like you to report your answer, it does not matter to me whether you report it in scientific notation or as a regular ordinary number. In our next calculation, we have two numbers that we're multiplying. They're both in scientific notation. You can leave them like that, or you can multiply the 10 to the second through to get 241.83, and the 10 to the fourth through to get 30500 meters. When I put this in my calculator, I got 7375815. The 3.05 has fewer sig figs than the 2.4183, so I want 3 sig figs in my answer. The 737 would round up because a 5 follows it. I would need to use placeholder zeros if I was going to write this as a regular number, which is what you see on the left, or I can put it in notation form using the power 6 to represent the number size. This particular calculation had units. Just like in math class, x times x would give you x squared, so m times m would give you m squared. And then the final one is a addition, subtraction, and a multiplication division problem. So we have both types of operations occurring. This is similar to percent error. I am telling you that the 100 is an exact value, and that was the point I was going to make on the previous slide. I forgot. Exact values do not have sig figs. They are values that are either counted or defined. So I can count how many students I have in my class. I can tell you that there are 60 seconds in a minute. Those are defined quantities. The number of students is a counted quantity, and so neither of those would be affected by the sig figs, and they do not have any influence on a calculation involving sig figs. So I'm going to subtract first because I've got that in the numerator. And so when I subtract, I look at decimal places. I see that 508 has no decimal places, and that 200 is precise to the ones place, so it too has no decimal places. So I would subtract them and get 308. 308 has 3 sig figs. The 200 in the denominator has 3 sig figs as well. So I want 3 sig figs reported in my answer. I got 1.54 when I divided 308 by 200, and then when I multiply it by 100, I'm going to get a value of 154. Alright, so that represents my 3 sig figs, and I accounted for the fact that I needed to follow my subtraction sig fig rule before I followed my division sig fig rule. So this should help you with the first part of your summer assignment, and if you have any questions, please don't hesitate to email me.